The purpose of this video is to teach you how to solve equations using either addition or subtraction. This is going to be a rather short video because these are single-step equations and we only need to do, as the name implies, one step to solve them. Now, single-step equations with addition or subtraction will look something like this. You could have any variable, so we're just going to use m, plus 5, some kind of number, equals another number, so we'll say 12. Or we could see something that is using subtraction instead. So m minus 5 equals 12. So let's talk about how we would solve these. When it comes to solving single-step equations, we need to first look at the operation that's being performed. Right now, our only operation over here is addition. So this is saying m, whatever m is, if we add 5 to it, we're going to get 12. Our goal is going to be to get m alone. In all of our examples that we're going to do, our variable needs to be solved for. So we are going to do everything we can to get it by itself. If we are adding 5 to it, the way to get it by itself is to do the inverse of addition. The inverse of addition means we want the opposite, so the opposite of addition is subtraction. So I am going to subtract 5 from both sides of the equation. This is very important. Whatever we do to one side, we have to do to the other. Otherwise, our equation becomes unbalanced, and it's not going to make any sense. So we subtract 5 from the left side, and as a result, we subtract 5 from the right side as well. Now, our plus 5 and our minus 5 cancel each other out, because if I'm adding 5 and taking away 5, that gives me 0. So all I have left over here is m, which is what we wanted. On the other side, I have to solve this little equation, 12 minus 5. 12 minus 5 gives me 7, so my answer is m equals 7. But we can't take that for granted. We want to make sure that this actually solves the equation. So what we then have to do, as I scoot it up a little bit, what we then have to do is take our value for m, take this 7 and plug it back into the equation. We're going to substitute it back in and make sure that it works out right. So you are expected to check your work. So if I take the 7 and add 5 to it, I hope that it's going to equal 12. 7 plus 5 is 12. And we end up with a true statement, 12 equals 12. And we're done. That is the only thing we had to do to solve this. We had to take the opposite of our operation, find out what our variable equaled, and then substitute the variable back into the original equation so we can check it. Now let's try the other side. Here I have m minus 5 equals 12. Just like before, I want to look at the only operation that's being performed, which is subtraction. This is saying some number minus 5 is going to give me 12. Okay? Just like before, whatever operation is happening, if I want to get our variable alone, I have to do the inverse. I have to do the opposite. So instead of subtracting 5, the opposite of subtraction is addition. So I am going to add 5, once again, to both sides. You have to do to one side the same thing that you do to the other. If you don't, as I said earlier, your equation will become unbalanced and it won't work. So, just like before, minus 5 and plus 5 equals 0. So those cancel out and we have m left. And now if I add 12 plus 5, I end up with 17. And that is our solution. But we cannot forget to check. We have to take that 17 and substitute it back in for m and make sure that it satisfies the equation. So if I have 17 minus 5 equals 12, when I subtract 5 from 17, I get 12, which equals 12 on the other side, so it checks out. That's all there is to it when we're solving equations by adding or subtracting. We'll do another example that has some decimals and another example that has some fractions, but the main concepts are going to be the same. Whatever operation is being performed in the equation, we have to do the opposite to get our variable alone. Alright, let's try the next example. Alright, in this example we have some fractions looking at us, and we are working with x plus 2/7 equals 5/7. Now, even though that we have fractions here, it shouldn't scare us away. We can add or subtract fractions very nicely as long as their denominators are exactly the same. And in this case, they just so happen to be the same. That is good. So, look at our operation. It is addition. If I want to get our variable alone, I have to do the opposite of addition, so I'm going to have to subtract. I'm going to take away 2/7 from the left side so that I get my x alone, but don't forget, I also have to take away 2/7 from the right side. Whatever I do to the left, I have to do to the right. So, 2/7 minus 2/7 is 0. Those terms go away and we're left with just x equals, now I have 5/7 minus 2/7. And since they have the same denominator, I already know my denominator is going to be 7. And all I have to do is subtract the numerators. 5 minus 2. 5 minus 2 is 3. So we come up with the answer of x equals 3/7. But don't forget, we are expected to check our work. So I'm going to take 3/7 and substitute it into our original equation. So I have 3/7 plus 2/7 equals 5/7. And as long as the left side equals the right side, we're good. Now, just like before, since I have the same denominator, 3/7 and 2/7, I can add the numerators. So I end up with 5/7 on the left side, and this equals 5/7 on the right side. Our solution checks out. We're good to go. Alright, let's try one more example with decimals, and then I think that'll be it for adding and subtracting single-step equations. Alright, for our last example, we have n minus 3 and 2/10 equals 5 and 6/10. I have decimals here, and what operation is going on? We have subtraction. Whatever n is, we're taking away 3 and 2/10 and being left with 5 and 6/10. So if we're going to find n, we have to do the opposite of our subtraction, meaning we have to add. So we're going to add 3 and 2/10 to both sides, taking away 3 and 2/10 and then adding 3 and 2/10 cancels them out. So I just have n on my left side. And then on the right side, I can add those together rather nicely, as long as I remember I have to line up my decimal points. So 6 plus 2 is 8. Bring down the decimal point. 5 plus 3 is also 8. And we have our answer of 8 and 8/10. All we have to do now is check. So I'm going to substitute 8 and 8/10 into our equation, but I'm also going to change the way I write it. Just because when I am subtracting decimals, I prefer to have them vertical instead of horizontal. So I'm going to write it like this, and I'm going to hope whatever solution I get over here matches the solution over here. Now, thankfully, I don't have to do any regrouping. 8 minus 2 gets me 6. Drop down the decimal point, and 8 minus 3 gets me 5. So, our solution here, 5 6/10, matches the solution we were supposed to have, meaning 8 8/10 is our final solution. We have one last example, and that is going to be the following problem. -2 3/10 plus m equals 7. So as we're looking at this, we need to pay attention to something. We're adding m. This is different than before. Before, m was always, or whatever our variable was always on the left side of our operation. What we need to look for, though, is what's happening here. We have two ways that we can approach this. We could rewrite this so that we then have m minus 2 3/10 equals 7. So we could rearrange it, making sure to keep the signs on the numbers. M was positive, so it stays positive. 2 3/10 was negative, so we are subtracting 2 3/10. Or the other way is to still remember our goal is to get m all by itself. And if we're trying to get m all by itself, that means I need to get rid of -2 3/10. So I should ask myself, if I want to bring this to 0, it's at -2 3/10 right now, and I need to bring it to 0 so that m is all alone, what should I do? The answer is, if it looks like a -2 3/10, we are going to add 2 3/10 to both sides. Because remember, if I have -2 3/10 and I add that back, those are going to cancel itself out. It's like saying, oh, I'm $2.30 in debt, so if I add $2.30 to my bank account, suddenly I'm not in debt anymore. So those will cancel out, and we have m equaling 9 3/10. All we have to do now is check. We have -2 3/10 plus 9 3/10. I'm going to rewrite that so that it looks a little bit better. So 9 3/10, I'm going to rewrite it so that it is subtraction. It's going to make things a little bit easier to work with. So 9 3/10 minus 2 3/10. And as long as this equals 7, we've got our correct answer. So 3/10 minus 3/10 is 0. Drop down your decimal point. 9 minus 2 is 7. And since what's after the decimal point is only 0, it doesn't necessarily have to be there. So these answers check out. Alright, I hope you found this video useful. Good luck with solving equations using addition and subtraction.